Hello everyone, welcome to today's video. So today we are going to talk about solid gas separation. First of all, sorry for not bringing up a video last week because I was very busy with my work. There has been a lot of problems lately. That's why I couldn't keep up to my promise of launching a video every week. But today I am up with one of the most important topics when it comes to placements, particularly for the chemical engineering students. This is the topic I thought we should talk about because we haven't lately talked about this different phases separation. Like most important thing about chemical engineering is separation of phases. When we talk of mass transfer in particular, when companies come, they do stress on mass transfer systems, liquid separation, liquid-solid separation, solid-gas separation, solid-solid separation, gas-gas separation, and liquid-liquid separation. All of these processes are very famous in the industry. One of the most important processes is solid gas separation or gas solid separation. That is a mixture of gas with suspended solids within it is being separated out from one another. The solid is collected and the gas in its purified form moves ahead. This is very important in gas purification industry where we need a pure gas, because solids, whenever it is or wherever it is, acts as an abrasive medium, or whenever we send the gas to a reactor bed, if there is a presence of solid, it might poison the catalyst, deposit as a dust surface on the catalyst itself, and might affect the reaction rate. And that's why the removal of the solids in particular are very important. And in some cases we need the solids because they are precious metals or they are precious elements. In those cases we need to separate out the solid from the gas because we need the solid in particular. In some phases we need the gas, which is rich in gas only and no solid should be present. In some cases we need the solid separated from the gas. In both the cases we need some prolific methods of the gas solid system separation. And some of the prolific methods in the industry, as we are going to talk about, the four methods that are primarily followed in the industry for gas solid separations, and we are only going to discuss two of them today. The two of them are going to be discussed in the next video in the upcoming week. The four basic systems of gas solid separation are cyclone separators, back filters, ESPs, that is electrostatic precipitators, and wet scrubbing system. Today we are going to talk about cyclone separators and back filters in particular. So let us talk about cyclone separators and back filters in particular, and let us keep these two, wet ESP, that is electrostatic precipitator, and wet scrubbing for the day after, that is for the next week. Let us keep this. So let me rub this, and we are going to primarily talk about back filters and cyclone separators. So first let us talk about cyclone separator. What is a cyclone separator? Let us understand. Now, as the name suggests, there must be a cyclonic structure formed such that the solid gets separated from the gas. This is very important, my friends. Try to understand this. A solid laden gas, let us consider this to be a gas with suspended solids in it. We need to separate out the solids from this particular quantity of gas. We send this. Where do we send it? We send it into a structure like this. Somewhat like this, enclosed structure. And what happens exactly is we give this gas with laden solids a tortuous path such that the gas escapes solid free and the solids, being heavy, get deposited out. This can be a technique in solid gas separation as well as a technique wherein there is liquid entrained in gas as well. So it can be a technique used in gas liquid separation as well, where the gas medium is primarily, that is, a gas laden with droplets of water or droplets of any other liquid. You can use this method because liquid and solids are primarily heavy and they do have a tendency to settle at the bottom, whereas the gas has a tendency to go at the top. Now, how does the cyclone separator exactly work? Let us understand. When we send this gas with laden solids or laden water droplets or liquid droplets, and we make it rotate in a circuit, and this is the wall of the cyclone separator. When we give this solid a tortuous path, how do we give the solid a tortuous path? Let us understand. This is basically the entry to the cyclone separator is in centrifugal pathways. That is, whenever there is a tangential velocity, it rotates around the circle. So basically a structure like this would explain it better. It goes within and it gets a tortuous path such that it rotates in a circle in the cyclone separator. It's given a centrifugal direction of rotation when it enters the cyclone separator, and that is the principle of cyclone separator. So when you see the solid laden gas enters the cyclone separator and gets this tortuous path or centrifugal path, it experiences a force of mv square by r. mv square by r, as we know by our basic knowledge of physics, that depending on its tangential velocity, the particles will experience a centrifugal force that is outside and throwing it on the periphery, on the walls of the cyclone separator, such that it follows a tortuous path. And as it follows the tortuous or circular path in the cyclone separator itself, as it strikes the walls of the cyclone separator, the solids, as it strikes the walls, the solid loses their momentum. Let me tell you, my friends, because of the friction it experiences, or because of the loss of inertia it experiences at the periphery of the cyclone separator. So at the walls, the solids lose inertia of motion. Lose inertia. And what happens when they lose inertia? The solids fall down because they have no momentum. And the gas having a momentum tend to escape, being lighter, tend to escape out. So gas, since it has no solid particles, there is no abrasion, there is very less friction involved. Gas follows the centrifugal path, rotates, and through this centrifugal path it tries to escape out from this hole. Whereas the solids, being heavier, loses their momentum as it strikes the wall, as it strikes the periphery. It loses its momentum, it loses its inertia of motion and settles down. Similarly, water droplets also loses their momentum and settles down. And here is a collection tank which collects these solid particles, which collects these water droplets in case of cyclone separator, which involves water droplets laden in gas. So this is one of the methods wherein we separate solid from the gas, or solid or liquid droplets from the gas, where gas is the primary or the major medium. The liquid or the solid is the secondary medium, which is present in minority. We need to separate that out. Whenever the liquid is in majority and the gas is in minority, that is liquid gas separation, we follow other methods like stripping, wherein the gas is being stripped out by a pure another gas, supposedly B. The gas A is stripped out. We are going to talk about that when we come to liquid gas separation. But whenever the gas is in majority, this is one of the major ways to separate it. So cyclone separators are done. As we move ahead, we will talk about back filters, which is the last topic of today, and is going to be followed up by ESP and wet scrubbing in our subsequent lectures. So coming straight away to back filters. Back filters. Bag filters. What are back filters? Back filters are nothing but membrane-like structures wherein you keep this bag, and it's a membrane-like structure, net-like structure. Understand this in simplistic terms. It's a net-like structure which has small pore sizes. The small pore sizes allow the gas to pass through, and they are used in series of bags. It's like the bags you carry for a market. It has small pores which allow the gas to pass through. But series of bags allows the gas to pass through. But the liquids, the solid, gets deposited on the filter, or as the name suggests, the back filters. The gas passes out. Gas, solid free, passes out, and the solids get deposited on the bags or on the filter cloth itself. Now, as the time progresses, time increases, this deposition, the thickness of the solid layer over the bag increases. Supposedly this is my bag and this is my solid layer. So it keeps on becoming dense and dense, and the thickness of the layer over the bag in itself increases. As it increases, it provides extra resistance to the gas flow, and hence the pressure drop pressure drop across the back filter increases. So as the time passes, the gas finds difficulty in passing through the back filter. The solid layers form an extra resistance to the gaseous medium. Though the separation efficiency increases because of the extra resistance to the gas, the minor solid particles, even the small solid particles, would be separated out because of the thick layer of solid already present, which is adding extra resistance and is not allowing easily the smaller particles to exit as well. The separation efficiency over time increases. But there comes a time when the gas flow rate decreases because of this extra resistance. The gas cannot pass through. There is a huge amount of pressure drop, and you either need to pull the gas with greater suction force, or you need to push the gas through an ID fan with a greater amount of force to pass through the back filter. Else, the gas will try to return back. Will try to return back due to the extra resistance, excess resistance beyond a certain point given by the back filter itself. So in that case, you need to clean the back filter. In case of cyclone separators, we were seeing the solids deposited were removed from the bottom continuously, continuous process. But here, the solids are getting deposited on the surface and there is no mechanism to remove the solid materials. In that case, my friends, this is very important. A reverse pulse jet of air is injected from the opposite side such that the air creates a reverse pressure to purge out or to clean out, scrap out the solids from the surface, and the solids are collected at the bottom. Now, there is always a vibration involved. There are vibratory elements that vibration, such that this air flow and continuous vibration removes the solid particles that are collected on the filters in itself. So pulsation, air pulses are given at regular intervals at high pressure in the opposite direction such that the filter cloth gets free and recycled, regenerated, free from solid particles, and the solids gets deposited down. Generally, the back filter are like this. This is a bag with filter cloth all wrapped up over its surface, and solids get deposited on this filter plus cloth as the gas passes through this filter cloth. And when the complete filter cloth is laden with solids, we pass air in the reverse direction, such that it gives pressure on the laden solids, such that the laden solids fall off from the surface and gets deposited at the bottom, collected at the bottom, and the surface gets regenerated for the further incoming gas. And this is done when the resistance is maximum and it is not allowing gas to pass subsequently. So you see, this is the principle of back filters by which solids are separated from gas. You understand the principle of cyclone separator, where we are using centrifugal force and momentum loss by striking on the periphery on the surface. Here is a principle of membrane or filter cloth separation, wherein due to small pore size, the solids are deposited on the filter plus cloth, whereas the gas finds its easy escape because of its virtue of having a very low density and can pass through any type of cloth. These methods I am particularly discussing because every industry generally asks for this, and you will find these equipments in almost every industry: cyclone separator, back filters, ESPs, and wet scrubbing system. Any industry hardly exists where either of these four processes are not present. At least one of them are present in every industry, and that's why they become very important when it comes to mechanical operations. So this is the thing. The next video is going to be about ESPs and wet scrubbing system. So if you liked it, like it, share it with your friends, subscribe to our channel, and please hit the bells icon to get regular updates so that you can know that our next video has come up. That's it for today. Thank you very much.